Okay, so in this video we turn our attention to e to the x. Okay, so e to the x is an exponential function in x, and so we want to define another function, an inverse function, because we know that the natural logarithm function is a one-to-one function. It's an increasing function over the domain, so it is one-to-one, and therefore an inverse exists. Now it turns out that e to the x is the inverse function of the natural logarithm, and that can be shown easily, okay, by taking rational values of x, and then we can apply the properties of logs, because then if x is rational, we could take the natural log of e to the x, right? And then based on the properties of logs that we proved earlier, we can pull the x out, and that becomes the natural log of e, which again we've shown that this is equal to 1, right? And so we get x. Okay. Now, what about irrational values of x? Well, irrational values of x, we just define e to the x as the inverse. Okay. So if values of x that are irrational, so for irrational values of x, we simply define e to the x as the inverse function of the natural log function, natural log of x. Okay, so now that brings us to our definition. So our definition is for any real number x, so again, rational, irrational, so for any real number x, define y to the ex to be the number for which the natural log of y will give us the natural log of e to the x, which will give us the natural log, or excuse me, give us x. Then we have e to the x equals the exponential function expx. So this is how we define the inverse function. This is going to be equal to the inverse function for all values of x, and so thus e to the natural log of x is going to be equal to x for x greater than 0. Why? Because that's the limitation on the natural log, the inside function here. And then if we transpose those, interchange those, and we say, okay, well, the natural log of e to the x is equal to x, that's going to be true for all values of x. Okay? Because there's no restrictions on e to the x. Okay, it's always positive, right? So e to the x is always positive. Okay? And that's the definition. So now we're going to use this definition, and then we're going to now look at properties of exponential functions, and go from there.